Okay, so let's say we had the following question in which there's two blocks, one that's 5 kilograms and one that's 3 kilograms. And they're both on the surface that has a coefficient of friction being 0.2. So, and there's also a 20 Newton force going horizontally. So if the first question were to say, what's the acceleration of the systems? So the best thing to do would be to add the masses together and make one diagram. So here I added the two masses and we got 8 kilograms. And then I put the following forces. So we have mg, and then we have the force normal going in the opposite direction, parallel to the floor. And then we have the force of friction, which is kinetic in this case, going in the opposite direction of which way the mass is going. Since it's being pushed to the right, the friction will be going to the left. And we also have the 20 Newton force, which is going to the right. So the first thing to do would be to find the force normal, since we're going to need it later on. So N is equal to mg, so 8 kilograms times g, which is 9.8 meters per second squared, and we get 78.4 newtons. So next we can use this to find the force of friction, and then we do the coefficient times the force normal that we found, and we get 15.68 newtons. So next we can update our diagram, and since we're just looking at the horizontal acceleration, since the system isn't moving up or down, we can just disregard the force normal and energy in this case, just for simplicity. So we have the 15.68 that we found here, and also the 20 newtons, which was given with the question. So next we can do the F net total of x, and then we have negative 15.68 since it's going to the left, and a positive 20 newtons since it's going to the right, which is equal to ma, or an m in this case is 8 kilograms times a. So to find a, we just divide the product of these and divide it by a, and we get a is equal to 0.54 meters per second squared. It's a good idea to always make a system of axes so you don't confuse yourself or the person grading your work which direction the object is going and the reason for which you select your positives and negatives. So next, let's say part B said force that block 1 puts on block 2. So for this, make a free body diagram of just block 2. So we have 3 kilograms, and we have the force from block 1. We also have the force of friction again, and we have force normal and force mg. So first, let's find force normal again, since we're going to need it later on, and we get 29.4 newtons. And then we can find the force of friction on this block itself, which is 5.88 newtons. And then if we do the F net x of the block 2, we get negative 5.88 plus force of block 1 equal to ma. And we know both of these values. We got m as 3 kilograms and acceleration, which we found in the first part. So now we only have one variable, so we can solve for that, and we get F block 1 as 7.5 newtons.